everyone, zetamath here. I decided to put up a video of my reacting to Simon's solve of my most recent puzzle, Distinction. This puzzle appeared on the channel while I was streaming, so if you don't know, I stream Wednesdays and Saturdays. I stream for somewhere between 4 and 8 hours, and I just do a bunch of puzzles. So if you want to come see me do puzzles and hang out, by all means, please stop by the stream. You'll see as I do this, I'm interacting with chat, hanging out with them, seeing how people are reacting. Also, if you're interested in seeing some more stuff from me, but you don't have time to hang out in the streams, maybe the schedule doesn't work or you don't have time to watch it, I do post my favorite puzzle every week from the stream as a standalone video called the Puzzle of the Week. So if you're interested in seeing more of me, I recommend checking out my Puzzle of the Week videos. There's links down in the description. I should say up front that 95% of the time Simon finds exactly the break-in that I had in mind for a puzzle, and his solution looks uncannily like my solution path. This falls in the 5%, where Simon discovers something brilliant that looks completely intentional when you watch him do it, but may have been completely different from what I intended. So if you are interested, I'd really encourage you to give the puzzle a try yourself. You may find a completely different way through it than what Simon does. At least a completely different way through the beginning. But that's part of the fun of setting puzzles and watching people solve puzzles, is seeing that everyone ends up finding their own way through it. Anyway, I hope to see all of you on my stream someday soon. Bye for now. Enjoy Simon's solve of Distinction.
Now let's get on with Distinction by zetamath. What are the rules for this one? They are as follows. Normal Sudoku rules apply. Each purple line must contain a set of consecutive non-repeating digits. These digits can appear in any order. So these lines are normal Renban lines. So let's look at this one.
I actually did not send a solution guide with this one.
To make it 9876, and I've just realised that will not work. So now I will put a 1 on it instead. So if that was a 1, that...
My general policy is if something has more than 30 solves on LMD and is rated at like 3 stars, then I won't send a solution guide. If there's fewer than that, then I usually will. But if something has been done so many times that I'm very confident that whoever's testing the puzzles could do it, then I don't worry about it as much. That is my usual thing. But I like writing up the solution guides if I think the puzzle is tricky, or if, say, it has not gotten 10 solves on LMD, that usually means that it definitely needs a solution guide.
That was a 2, that was a 3, and that was a 4. That would be a valid way of filling this Renban line. Now, once you know there's a 1 on it, it has to be 1, 2, 3, and 4 because the digits have to be consecutive. But unlike thermometers, which obviously have to, if you find a thermometer in the Sudoku, it has to increase from the bulb end. With a Renban line, you can put the digits in any order you want, so we can muddle them up. We can have the 2 down there, we can have the 1 here, we can have the 2 there, etc., etc. Lots of different permutations. Now, there is more to the rules, though, today. Additionally, no 2 purple lines can contain exactly the same set of digits. E.g., if one length 3 line, let's look at this one, contains the digits 3, 4, and 5, no other length 3 line can contain those exact digits. Okay, so that one could not be 3, 4, 5 either then. However, a length 4 line containing 2, 3, 4, 5, how's that going to have to look? Something like that. And a length 3 line containing 4, 5, 6, let's put 4, 5, 6 in that one, would both be acceptable. Okay, well that's completely how I would have understood the rules without the example, actually. So all that's saying is that if we work out that one of the 3-cell Renbans, one of the 3-cell purple lines is 3, 4, 5, you can't put 3, 4, 5 on another one. And then the 4-cell Renbans sort of sit in their world
This one I
apart.
actually
So
did send in.
although this does have 3, 4, 5 on it, it also has the 2. So it doesn't have exactly the same contents as this one because it also has a 2. So that sort of makes sense to me. Do have a go at the puzzle. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. Now, I have to say I am minded to think that this will be about mod 3, because I know something about 3-cell Renbands, of which there seem to be plenty in this puzzle. And that is that the digits on a 3-cell Renband must always be, if you add them up, you will get a number divisible by 3. And that is because, if you think about the algebra of a 3-cell purple line, one of the digits on it will be the middle of the consecutive sequence. Let's call that digit x. I don't know if it'll let me do that, actually. Maybe it will if I change. Hang on, let me just see if I can do this. Is there a way to turn on...
If you're at all uncertain, I would send a solution guide.
Something, or
I
maybe
definitely have had more success in getting puzzles to appear when I've sent them a solution guide.
I'm gonna have a go.
And I do agree with Finish Guy that writing solution guides is a really good way to sort of like quality test your puzzles.
Completely frivolous and a fool's errand. Letter tool on. Hold Alt for Shift for letters. Oh, good grief. Okay. So, oh, wow. Okay, so now everything's kicking off. So I think now if I press Alt on the keyboard, I go there. Oh, Sven. Look at Sven's software. It's just amazing. So now I'm going to label this X. I can label it X just by pressing Alt. So let's say that this is the middle digit on this Renban, i.e. the digit that's the middle size of the 3 digits on the line. Then one of the digits will be slightly lower than x, so it'll be x minus 1. The other digit will be slightly higher than x, it will be x plus 1. So if you sum up those 3 digits together, you will get 3x, and 3x is obviously divisible by 3. That was all a very long way of showing that, but it was quite an advert for this remarkable software that Sven has made. Now, yeah, so what was I thinking about? 3x. I got distracted with all the algebra. So yeah, so if I know that a 3-cell Renban is divisible by 3, let's have a look at where the 3-cell Renbans live in this puzzle and see if we can use that to our advantage. I'm just going to
This is from today. It came out while I was streaming, so I figured I would do a reaction to it, as at least Naverio and Clover have done before.
Okay, that doesn't seem to do anything. I might well be missing a trick here. I'm not seeing how to use that. Sorry. Okay, so that's not the first way to look at this puzzle.
I was going to be very surprised if he got somewhere from looking at this mod 3, but I've been surprised before.
So my next hunch, and that's all it is to look at the 2-cell Renbans. And the only reason I want to look at these is this looks it looks like zetamath has sort of hidden a pattern in here. These 2-cell Renbans, you know, it's not like there's just one of them hidden in a corner acting as a disambiguating pattern. That looks like, it almost looks like zetamath wanted to make this one vertical but then didn't. Right, I can tell you something about the central cell. That is orange. It's also odd because both of those things begin with O. Now, why is this
if you
orange?
Shout loud enough in the chat, it'll help.
Well,
Simon.
it's because of the nature of a 2-cell Renban. If you think about any 2-cell purple line in this puzzle, it contains consecutive digits, so it contains an odd and an even digit. Now, in any row of the Sudoku, you've got the digits 1 to 9 once each. So there are only 4 even digits, the digits 2, 4, 6, and 8. And we know that they must be disposed along these 4 lines because each one of them individually needs an even digit. So that one must be the spare one, and that must be an odd digit. Now that means that... Oh, that means this domino at the top, unfortunately, is an odd and an even digit, because we're going to have 3 evens in those 6 cells, and we're going to have 4 odds in those 7 cells. So we need 1 more odd and 1 more even at the top of the column. And that's absolutely useless. Oh my goodness me. Right, okay, I'm not on the same wavelength yet as zetamath. Now, zetamath, what else have you hidden in your puzzle then? 1, 2, 3, 4, 5,
there
6,
we go.
7, 8 2-cell Renbans. Which is all of them. Okay, right, that's interesting. That is all of them, isn't it? Yes, it is, because, right, Okay, so now we need to use the rule that says that none of these purple lines can contain the identical constituents. And let's think about all the possible combinations of two-cell lines that could exist in this puzzle. There's going to be a 1 and a 2 somewhere in it, a 2 and a 3, a 3 and a 4. Well, yeah, this would be all possible two-cell combinations. So 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9. There are 8 different combinations, and that makes sense because as we go up the digits, we go from the 1, 2 pair to the 2, 3 pair, etc. When we reach 8 and we do the 8, 9 pair, we can't go up again and do the 9, 10 pair. That doesn't exist. So there are only 8 pairs, and there are exactly 8 two-cell Rembands in this puzzle. So every single possible combination is represented, and that is very beautiful indeed, because now that digit is odd, and it's the same as that one. Isn't that amazing? And the reason for that, of course, is that whatever this digit is, it must be one of the digits from 1 to 9, and it must therefore appear on a two-cell Remban in this puzzle, because all digits appear on at least one two-cell Remban. Yeah, so the 1 and the 9 only appear on one two-cell Remban, because once you've done the 1 and the 2, you can't do a 1 and a 3 or anything. So the 1 has only one option, but the 2 will be on 2 different.
I did not make anything look like a face. I'm trying to see the frowny face. I'm not sure I can even see it.
So yeah, so every digit is on a two-cell Remban once.
Oh, I see it.
And this digit
you're talking
is
about
of
this piece.
All of those and that one. So it must be there.
So no, the 4-cell Renbans were nearly forced where I had to put them in order to make the puzzle actually resolve. So yeah, by the time the 4-cell Renbans were the last ones I placed. So by the time I was placing 4-cell Renbans, there was very little thought about aesthetics. It was almost entirely what will make the puzzle actually work. Because I expected that I could, when I sort of was setting this, I originally thought, oh, I'll do all the 2 and 3-cell Renbans, and then that'll solve the puzzle with maybe like a given or whatever. But then that turned out not to be the case. And so then I wanted specifically, okay, well, if I'm going to use 4-cell Renbans, it needs to be the case that you need to use the rule that the 4-cell Renbans... Yeah, I guess I could have rotated it. I did not even really think about rotation. But yeah, so I eventually ended up placing it so that you needed to use the distinction rule on the 4-length Renbans in order to resolve the puzzle.
And therefore this digit is odd. So let's actually label the options up. Yeah, okay, because that means that one is on a Renban with an odd number, so that's even. I think we use blue for even.
Nissig asks how long it takes to set something like this. It varies a lot. So in this case, I set a whole version of this puzzle with almost this rule set. That took a day or two, and then I didn't like that puzzle, but I learned enough by setting it that I then went and set this puzzle. And so, like, actually, from when I drew that plus sign with the Renbans that Simon zeroed in on to when it was done, that was maybe 4 hours, 8 hours, so somewhere in the span of 1 to 2 days. It wasn't super long, but that's discounting the fact that I had to set a bunch of bad puzzles with this rule set before I did this.
This digit, this orange digit, must be on this Renban. Which... hang on a minute. I'm not understanding quite what this does.
Well, Totally Normal Cat in chat was one of the first people who tested it for me. Who's asking
it's too cute. In fact, well, this is... Yeah, let's go back to what I said at the start, which is I thought zetamath had wanted to create this sort of a perfect pattern with this being a vertical domino. Well, actually, that would have broken the puzzle now, I'm realizing, because there would have been all 8 different possible 2-cell Renbans, and this digit could never have appeared on all of them, so there had to be a break in the pattern. Okay. I don't know what to do with that. Um, oh dear. 4-cell REM
He
bands?
is very, very close.
We have got
It's funny because this opening is very
3
similar
of
to
those, I
Nabner,
want
where
to
I
say.
think Simon's solve of
The problem
Nabner
with the
is one of the
4-cell REM band is
fastest
it's
that has
far
ever
less
happened because he was
interesting.
right there on what the Nabner opening was.
Because I don't think we know anything about the modulus of the sum of the digits on a 4-cell REM band. And, well, I suppose we can say it's got 2 odds and 2 even numbers on it, which I don't think is helping us, even though zetamath has been kind enough to give me 2 given digits today. Okay. Have I missed something on the 3-cell REM bands? That's probably what's happened. Let's do the 3-cell REM bands again. 1, 2, 3, 4, 5, 6, 7. I think that's all of them again. Let's highlight those again, in particularly garish yellow. So we've got 7 of these. How many are we meant to have of these if we had all of them? Right, okay, sorry, I had not appreciated this at all when I highlighted this last time. Yeah, that's right. There are only 7 possible combinations of 3-cell REM bands, aren't there? Because 1, 2, 3, 2, 3, 4, 3, 4, 5, etc. And when you get to 7, you do 7, 8, 9. But there's no combination associated just with 8, 9, because you can't go 8, 9, 10, and obviously then you can't go 9, 10, 11. So as you increase the length of a REM band, you reduce the number of possible REM bands associated with that length. Right, okay, so that means that we have to have every single possible version of 3-cell REM bands in this combination. Oh, I know what this might be. I know what this is. If this is right, this is going to be very interesting. Let me just have a stare at this for a second before I do some highlighting I'm going to regret. I can't see it. I can't see it without doing the highlighting. Sorry, I'm going to have to highlight this. So I'm just going to highlight those cells in black. And I'm also going to highlight all of the 2-cell REM bands as well. Like that. Now, what I'm wondering...
I think he's going to get this in a really, really complicated way.
Yeah, this is right. I've got it. Right, this is absolutely ridiculously clever. And it's also very deeply surprising to me that this is where we went with this. Because this is almost a set type thing going on. But it's this sort of strange way to think about it. So what I'm thinking is that if we think about the nature of all of the black cells, we know that they are all the possible 2-cell REM bands that exist and all the possible 3-cell REM bands that exist. So how many 1s and how many 9s do we think that there are in the black cells of this puzzle? Well, we know on the 2-cell REM band, the only time the 1 appears is in the 1, 2.
I'm definitely surprised we're going here.
9. So in the 2-cell REM bands, there is
so just to say how I would explain what's happening before he does this, because I think he's about to combine together the 2 and 3-cell REN bonds, and I thought about this purely in terms of the 2-cell REN bonds, and namely, how many 2-cell REN bonds is this digit on? And this digit can only be on one 2-cell REN bond. Well, most digits need to be on 2 different 2-cell REN bonds. And so this digit, for example, if this digit were a 3, it would be a problem because that would need to be both on 2, 3, and 3, 4, and it can't be. And so that tells you that this has to be 1 or 9, which is then going to sort of percolate. And I think what Simon's doing is he's adding together that fact for all the length 2 renbans with the corresponding fact for all the length 3 renbans, and now he's going to try and count the 1s and 9s and 2s and 8s. And, well, I'm excited to see where this goes, but I have no idea. And yes, Naverio, this is the reaction stream.
There's 1 1 and 1 9. But in the 3-cell renbans, it's the same. The 1 2 3 combo is the only time the 1 appears. The 7 8 9 combo is the only time the 9 appears. So within all of the black cells, there are 2 1s and 2 9s only. But look, if we look at the sort of Maltese cross in this grid, if we look at this shape, that's 5 complete boxes of the Sudoku. So in that shape, there must be 5 1s and there must be 5 9s. And therefore I've got to fit into these cells. Let me get this right. Those cells there, they have to contain the blue. Sorry, and I'm now polluting my blues. And hang on, let me uncolour these ones. Hang on, I've got to keep the black. I'm going to just remember that thing about the middle and these two being the same. So, right. So what I'm saying
this is cool. I mean, it's going to get him some stuff
in the blue cells and 3 9s in the blue cells, and that's
though at the end he's going to say he doesn't see how this is a 3-star puzzle.
It's completely beautiful. It's completely beautiful, not just because the pattern I've made is actually quite pretty, but how are we going to put 3 1s in the blue cells? Now in row 4 I can put 1 1. And in row 6, I can put 1 1. I can't put 2 1s in either of those cells. So in all of those cells, there can be exactly 2 1s.
Hey, Chip.
So now I need to put a 1 either here or here to complete the quota of 1s. But of course, the same logic I've just done applies identically to 9s. I can put a 9 in row 4 in a blue cell. I can put a second 9 in row 6 in a blue cell, but I've still got to put 1 more 9 into the blue cells. So the 9 will have to go there. So this is a 1 9 pair. And if this is a 1 9 pair, that digit there, which we know is the same as the central cell, is a 1 or a 9. That's just, I mean, oh, so this even digit is...
Oh, I mean, I didn't rate the difficulty myself. The 30 plus people who did this on Logic Masters Germany said this is a 3 out of 5. I would never trust my own assessment of the difficulty of a puzzle.
Trying to do this sort of analysis. Right, now. Yeah, well, my brain's going mad now. Right. Now look, I've got a 1 9 pair in column 4. Now that means when we were thinking about the fact we needed to put a 1 and a 9,
I actually thought this one was a 3 and it ended up as a 3.
They can't go in these 2 cells anymore because there's a 1 9 pair already looking at those 2 cells. So they get de-bluified, and if they get de-bluified, now the 1 and 9 I know exist in blue in row 6 have to be in here. So they're in there.
This is very cool, though. I mean, this is actually like going to get him some very useful stuff.
And I'm only left with 2 bluified cells in row 4, which have to now be 1 and 9. QED.
There are definitely 3 of 5 puzzles.
My earlier thought, which was that this was meant to be approached, but that is not. That's really.
This is definitely not the approachable way to do the puzzle.
Beautiful logic. Don't get me wrong. It's beautiful logic, but you have to you really have to be careful about counting
the comments are going to be all people explaining to him the way to do this,
and then thinking about the composition of the totals, and then noticing the overlap with the cross, all of which strikes me as being not easy. It's taken me 22 minutes to do it. I'm sorry about that. Maybe this is just
He was so close. He was right there as he was explaining it at the beginning, and then he went off on this.
I love it. Now, I can do some Sudoku now, because look, I've got 1 9, 1 9. I've got to put, therefore, 1s and 9s into those 3 cells in row 5. on that one can't be a 1 or a 9 because it sees a 1, 9 in its
Yeah,
column.
this
So
is
that is
very
a 1, 1, 9,
hilarious
which
that, yeah,
means
it did
this
not
is
get him the thing that I thought.
Aha, I have a digit. That's an extreme even digit. It's either 2 or 8 because it's got to be consecutive with 1 or 9, and it's not 2. So that's 8. That's 9. That's 1. We know that's the same as that. So that's 1. That's 2. That's 9.
So just a bit of like behind the scenes setting stuff. This puzzle solves uniquely without this 2. Like humanly, it is solvable without this 2. However, I don't think it solves in a way that is super fun without the 2 because a lot of the stuff you end up chasing around ends up being quite difficult to keep track of if you don't actually if you don't keep this 2 here. So most of my puzzles have more information in them than is strictly necessary to make them unique and to make them humanable. I think it's usually a good idea to ask yourself, like, is it fun to have to chase all of the possibilities through the puzzle, yes or no? And I think for some puzzles it will be, and my impression was for this one it was not.
So 9 is now in one of these 2 cells, and whichever one... Ooh... Well, it would be very useful if it's there, because this Renban would be determined.
Hey, Kodak. We're reacting to
Whichever
Simon
one of
solving
one
of my recent puzzles.
Oh. Yes. Yeah, I know which one it is. It's not this one, because if the 9 is there, it has to go with 8, and it will be the same. It will be a zygotically identical twin to its friend there, and that won't work. That's not allowed by the rules, so that can't be 9. So the 9 goes up here, and that's huge. Because if that's 9, 8 must go here, 7 must go here. So now 8 is in one of these cells.
Yeah, I mean, part of the reason I thought to do this is because Simon was excited to see other people doing reaction videos.
It might... actually, I don't need the blue now, do I? Let me just de-bluify the whole grid, I think, while I stare at this and try and work out what's going on. Yeah. Look, there's a 1 on that Renban.
Which is something he saw right at the beginning and then went on the...
So now, in our 3-cell Renbans,
Wild
we've
Goose
got a
Chase.
987. Well, yeah, we've got 987 and a 123. So actually, if there was an 8 on this Renban, it would have to not be the 987.
Yeah, all of my
Renban.
streams are automatically available on
876
YouTube,
Renban.
Javier, so you won't miss anything. You can go back and watch anything. You can watch this tomorrow or any of my other stuff. So feel free to go to sleep, and it will be here for you tomorrow.
2 must be in one of those 2 cells, because of this 2, and this 2 all interacting. If 2 is on the line, that would have to be a 3, because it couldn't be a 1. So 2, 3... oh dear, now I'm stuck, I think. Oh, no, hang on, look at column 6 by Sudoku. Those must be 4s, 5s and 6s. So that digit needs to be 3, 4, 5, 6 or 7. Are we prepared to... Yes, I am. I'm not proud. 3, 4, 5, 6 or 7. Okay. So... now what do we do?
Sleep well.
That is the next question. We have got to think about... I don't actually know what to do now. I thought it would be more obvious, but I don't. I'm not seeing anything.
Sleep well, Nicholas. Thanks for some of your cool observations earlier.
We don't know where 3 is in this box. These squares are 3s, 4s, 5s and 6s. So that cell can't be 3, 4, 5 or 6 because it sees this one on its
Wow,
Renban.
Simon solved that fast.
So whatever these 3 are, obviously it can't be the same as this, but this is also not able to be this. And as this is a quadruple, that therefore restricts this value, which also can't be 8. And actually it can't be 1 or 9 because 1 and 9 are not consecutive.
Oh, thank you,
3, 4,
Kurban.
5,
Tristan made
6.
that.
So
I am
that square is a
excited
bit
by the new
restricted.
thumbnail as well.
It's not the same as 7, so it's 2 or 7. I was going to say it's not the same as 7 different digits, but actually it is the same. It could be the same as 7 itself. So this is 2 or 7. So if this is 2, this is 3, 4, this is 5, 6. I don't see what's wrong with that. What about if this is 7? If this is 7, this is 5, 6 then. So this is 3, 4.
Yeah, I think you dig this one, Kodak, but I know you were on vacation, so you have all this puzzle, so you can just watch Simon do it as would be my usual strategy.
Okay. 9 in this box is restricted because I can't put 9 on that Renban. And I remember I can't put 9 on that Renban because I tried to do it in the example when we were looking at the puzzle, and I noticed that 8 couldn't go on this Renban. So that means that in this box, 9 has to be in this domino, look. So 9 is in one of those 3 squares. Oh, right, that's beautiful. That is beautiful. In fact, I've just noticed that can't be an 8. But where does 9 go in this box? It can't go on this Renban, or this Renban would be 987 and be the same as this one, which is not allowed by the rules. So that's not 9. This is 9. That's 9. This is 1. This is 8. 9 is almost locked onto this Renban, which would make this Renban 9876, which would then not have to be the same as... Oh, okay, we don't know about these at all, actually. We know that one is not 9876, but we don't know about this one, so we don't know what this is. What else have we got here? We've got 8 has to be in one of these 3 cells. 1... I don't know. I've got 8. Oh, look. Yeah, I've got 8 on this Renban, and it can't have 9 on it. So those 2 squares have got to be 6 and 7. So 1 in this row has to be... beautiful. So 1 has to be on this little Renban. And once 1 is on a Renban, we know the composition of the Renban. That's 1, 2, 3, and 4 with a 1 in one of those. So that's not 2. So 7 only has 2 possible positions in row 3. I see. If that's 2, then that can be 2, and that wouldn't necessarily break the puzzle. So, now what do we do? Now where shall we look? We shall look at 7. No, 7's still got 3 possible positions in box 1. 1 has to be in one of those 2 cells in box 3 by Sudoku now. Oh, that just follows from the 1 being here. Okay. So we've now got a 987 Renban. We've got a 123 Renban. I've got an 876 Renban. So I need to have a 234 Renban, which could be that one. Oh, okay. So where is the 234 Renban in this puzzle? Now that's
I thought
one
Simon would see
possibility.
this.
Now, it can't be this one because this 2 rules it out. And it can't be that one. And it can't be this one. I think it might be able to be that one. Let me just have a look.
This is optional.
So is it just 2 possibilities for the 2,
but it is
3,
very
4
helpful
Renban?
towards solving it.
I want to say yes. I might be missing one of these. I might be missing another 3-cell Renban. I can't see any other options. And this can't be a 2, 3, 4 Renban, can it? Because it can't have 2 and 3 on it. I could put 2 or 3 in this cell, but I can't put both of them in. So I may be wrong about this, but I think this is the only one that can be 2, 3, 4. It's weird scanning you have to do in this puzzle, because I'm having to scan all the Ren bands and count their lengths and check. I think these are the only two candidates though. So if that's right, this has to be the 2 on this 2, 3, 4 Ren band. So that means these two squares are not. So this is a 5, 6 pair, which makes this a 7 and this a 6. So now 6 has to live in one of those squares in box 1. 2 comes out. Oh, 2 has to appear on that Ren band, so it has to go there. So this becomes 1. Oh, I see. This becomes a 1, 3, 4 triple. 2 has to live down here in box 7. This square has got to be 4, 5, 6, or 7. And that is very useful for some reason I can't appreciate. Right. Now we get stuck again. What we should look at now is... No. I want to say that you can't put 7 on here, because don't I need to put 8 in this column, and 8 can't accompany 9 in this column, because the 9's already been used. So in this column, wherever the 8 goes, and it's going to be in one of those 4 cells, it must accompany 7 on its Ren band. So that square I don't think can be 7.
Nice spot.
And that is the world's most useless deduction. Oh, well, apart from it gives me a 4, 5, 6 triple in column in box 5 I've just seen. Well, and therefore, actually, that's quite good, because now a 3 in this box is suddenly placeable here. And that means I should be able to deduce what this digit is. Because it can't be 2, so it's got to be 4. So that is now a 5, 6 pair. And this down at the bottom must be a 7, 8 pair. Which means these two squares have got to be a 5, 6 pair, I think. And that square has got to be... Oh, now, I've got a 5, 6, 2 cell Ren band, but I can have a 5, 6, 3 cell Ren band. So this square has got to either be 4 or 7. Right, I understand what I've got to do next, because now I'm going to look at the remaining Ren bands. Doesn't one of these Ren bands have to be a 3, 4, 5 Ren band? I think it does. And I haven't got one of those unless it's this one. So I think this... I'm not sure I know what that one is, but this 3 is ruling out.
Good luck on the exam, Logan.
Ren band. That one doesn't seem to have 3 on it. So I think that one has to be the 3. It's got to be 3, 4, 5, and the 4 must go there, the 5 must go there, the 5 goes there, the 6 goes there. And now that's a 6 by Sudoku. So now we've got... Yeah, okay, so this is either the 4, 5, 6 or the 7, 6, 5, and then this is the other one. So there must be a 5 on this Ren band. That is what we can say for certain. And that means that 5 is in one of these 3 cells. And 5 is not here because it would have to be with 4 or 6 on its Ren band. So that is a 5 on this Ren band. And we can probably work out, yes, we can. Yes, we can work out the composition of this Ren band because the 1 has been missed out. We know the 2 will pair off with the 3, then the 4 must pair off with the 5. So that's a 4, 5 pair. So 4 is now in a sort of an arrangement. We've got 2 4s in those 5 cells of columns 1 and 2. Now, how many 4s are we expecting there to be in columns 1 and 2? Exactly 2, and they are in those 5 cells. So there are no more 4s in any of these cells. So the 4 in this column has to be down in one of those 3 cells. But that's very annoying because it seems to be able to be on the Ren band or in the digit at the bottom. Right. Oh, no, I know what we do. 4, 4, there's got to be a 4 on this Ren band. So that's 4, 5. So this is now 6, 7, I think. Oh, that's done. 6. Aha! I'm getting all my pencil marks wrong. Look, this 6 now has to go there. That has to be 7 by Sudoku. This has to be a 2-3 pair, and the 2 can't go there. So that's 2, that's 3. Those 2 squares are 7 and 8, I want to say, which seems to be possible either way round.
Yeah. In my sort of like way I'd go through this, Ben, I would have used the fact that I knew what the things were in column 5 and then worked through how they had to be by using box 8. But he ended up getting there through his counting argument in a different way. So he didn't use it in the column, but then used it in the row.
These 2 squares, I seem to have this already pencil marked in, but that's a 7-9 pair because of this 9-7 pair at the top. So those 2 squares have got to be 5 and 6 to fill this box and make sure it's replete with digits it should have. So these 3 squares are 2, 3 and 4 by Sudoku. These squares are 1, 5 by Sudoku. 5s are aligning in column 7 and 8, so we can ask where 5 should go in column 9, and it's going to have to be almost on the Renban. Yes, and if this is 4, 5, 6, that one is not 4, 5, 6, so this must have 7 on it. This is so clever. So that's 7, that's 7, that's 8, that's no longer 8. This 7 is fixing a 7 and a 9 in this box. Look, by Sudoku, that's no longer a 9, but it can still be
I think
a 1.
part of what makes this puzzle a bit more approachable than a lot of my puzzles is that there are a lot of different ways to go through it, including at least one I did not know about that I learned about from Simon.
4 7s looking at box 9. So this must
But yeah,
be 7.
I'm a very big fan of different solutions
beautiful.
to the same puzzle.
Right, because why is that beautiful? Well, if you can't put 7 on that Renban, you definitely can't put 8 and 9 on it, because it's a 4-cell Renban, so it's going to need those digits. So the 9 shifts up to here, and the 8, I think, now has to go there. Which means 8 is... Can 8 be on the Renban with a 4? 4, 5... No, it can't. So 8 is placed now in this box, because you can't put it on this Renban with a 4. 4, 5, 6, 7 is as high as you could go. So that becomes 8. Surely that's resolved, isn't it? Which one of these is 8? No, okay, maybe it isn't. So, oh, right, the other thing is, we now know quite a lot about this line. And that's because it's got a 5 on it, but it doesn't have a 7 on it. So it must have, it's the maximum it is 6, 5, 4, 3. So it must have 4 and 3 on it. So it doesn't have 1 on it. Oh, that still doesn't do anything. Okay. Okay, that's not a 2. Oh, bother. I think I'm getting stuck. It was going really well for a moment or two, and now I've ground to a halt. There's a 9 in one of those 2 cells. So is there something I can say about this? This Renban doesn't have 7 on it, and it does have 4 on it. So we're selecting a slice of 4 digits from the digits 1, 2, 3, 4, 5, and 6. So there must be a 3 on this Renban, which must actually therefore be in those 2 squares because of the 3 here. Oh, hang on. Yeah, look, there's a 4 looking at this as well, looking at that cell. Sorry, I could have done that by Sudoku. That's a 4. So now that's not a 4. Okay, that's very interesting, but doesn't seem to do anything. So I can see here there's a 6 in one of those 2 cells. Now that aligns the 6's, look, in columns 1 and 3. So in column 2, the 6 is down here, and what I'd really like to know is that it's not there. For what reason can we say that that is the case? I don't think I can say that, I'm afraid. So I'm afraid we're going to have to carry on thinking. 4, 5. So this Renban might have
givens
6
are
on it,
vicious.
but it might not. We don't know either way. Is there some way of doing this so that we can learn more about the world? We can... Oh, okay, there's a 5 on this Renban and there's a 5 here. So there's a 5 in one of these 3 cells. Is that useful? Nearly. I'm very close, I think, to forcing digits onto this Renban, but I can't quite do it. These squares are from 6, 7 and 8. Have we got more? It's almost certainly going to be Sudoku, isn't it? That's normally the thing that I forget to do. So let me just check whether I can do some Sudoku to help me here.
Thank you, David. I'm happy to do it. I have a lot of fun with this.
Sudoku. You want to help me. Help me to learn about the puzzle. 9s. I can't see how to do it. Maybe it's... Okay, in this column, these squares have to be from 3, 4 and 5. Is that helpful? The answer is I don't know. 6 is almost very restricted in box 9. It's one of 2 places. If I can force 6 onto the line, it would be happy days because there's no 7 on the line. We'd know the line was 6, 5, 4, 3. And this would be a 1, 2 pair, which might be possible. Don't know actually. No, hang on. Hang on a minute. I see what we do. Right. The key is the 2s. There is a 2 in one of those cells, so there is no 2 on this Renban. If there's no 2 on that Renban, then what's on it? It's a 4-cell Renban that doesn't have a 7 or a 2 on it, so it must be 3, 4, 5, 6. So that's a 3, 4, 5, 6 Renban, and I want to say that therefore I can fill it in, but I'm not sure I can. I can say those are 3, 5 and 6. I can say that's certainly not a 3. I can say probably some other things as well. But also, now I've got to have 1. This is not 6. I've got to have 1 in one of these 3 cells. Now that's interesting because the 1 in box 1 is in one of those 3 cells. So these are not 1, and that must be the 1 in box 4. And now I should ask where the 8 goes in this box and use my pencil marks. So that's the 8, that's the 8, that's the 7, that's a 6, that's a 6, that's a 5. We know that's not a 5 already because it's been forced onto this Renban here. But this 5 is giving me a 5 here, that's giving me a 4 here. Those 2 squares are now a 7, 9 pair, which is resolved. 7 and 9 go in the grid. 9 gets put in the corner. That puts 2 and 1 into those cells. That cell is now not 1. This cell must be known. That's a 5.
Yeah, the design was specifically that learning that this Renban had a 6 on it tells you the other one doesn't. That was what I designed all of this.
Now we're getting hopeful, I think.
These machinations
let's
for.
Put 3, 6 into those squares. Let's put... How is this resolved? So this square's got to be 1 or 6 only. And 2, 3, 4, 5... Oh, I see. Yes, I do see. This is beautiful. Right. So now, yeah, look, the 7 here operates a bit like the 7 here. So if 6 is on this Renban, this has got to be a 6, 5, 4, 3 Renban, where it would become the same as its friend over there, which is not allowed by the rules. So you can't put 6 on this Renban. So the 6 must go there, which means that's 6, that's 3, that's 1. It's probably done something. It's given me a 6 here and a 5 here, which means this is not a 5 anymore. So if this Renban hasn't got So this is 1 by Sudoku. So there is a 2 on this Renban. That's a 1, that's a 5, that's a 5, that's a 4. Okay, so now this must be a 2-3 pair. So there's a 2-3 pair in the bottom row. So goodness only knows what these two cells are. Let's try and work it out. These are somehow 4s and 5s. And there's a 5 here. So 5 goes in the corner. That's a 4, that's a 2, that's a 3, that's a 4, that's a 3, that's a 3, that's a 2, and that's a 2. And suddenly, oh, that's a strange thing. Looks good to me. Sorry, that's a different version of the normal Sven finishing. Must be because I'm using the test solver in order to do the X thing I did at the start. That is just magnificent. What a magnificent puzzle. It's so surprising as well. I was convinced when I read the rules and when I saw the grid layout, it was all going to be about mod 3 and possibly parity. But it's not at all, and it's a very beautiful idea that there has to be a particular number of 1s and 9s in this sort of Maltese cross of the grid, and so much of that was consumed with non-repeatable Renbans. That was beautiful. And then the whole way that you got this, well, the whole way you got those digits then being 1s and 9s with this one, and that forced a 1-9 pair here. Can't remember quite what happened after that. And then we just had to keep track, which I think I probably did very badly, of which 3-cell Renbans we'd used and which 3-cell Renbans we had not used. And slowly it revealed its secrets to us. So zetamath, take yet another bow, my friend. Very much enjoyed. I hope you did enjoy it. You all enjoyed it too. Let me know in the comments. I do enjoy them, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.
Well, that was a lot of fun. So let's see. I want to talk just a little bit about. So first of all, I should say, as much as we in chat somewhat teased Simon for the fact that he did this in a somewhat complicated way, he really honed in on exactly the right thing to ask, which is how many. Let's see. I'm going to pull up a copy of this puzzle. I bet I can do that. Okay, and we'll switch back to CTC mode. Okay, so the thing that Simon did here was to count all of the 3-cell Renbans in here and look for 1s and 9s, but he absolutely picked up on exactly the right thing to ask, which was about, okay, how many 1s and 9s are there on these things? And so my sort of intended solution path was to notice whatever this digit is, it has to show up on all of its Renbans, because every possible length 2 Renban is in the puzzle, exactly like Simon said. By the way, let me remove my audio. Oh, did I? There we go. Okay, there we go. Let's remove that. I don't want you accidentally hearing, I don't know, random Windows noises or whatever. Oh, wow, my thing didn't replace this. Usually my computer automatically makes things go to the test version instead of whatever. But anyway, this digit needs to show up on every length 2 Renban it does. So every length 2 Renban it does is only one possible. It has to show up on a Renban. It can only be there. So these two are immediately the same. And then the deduction that I had in mind was, okay, so what does that mean this digit is? It's 1 or 9. So people in chat were going over that. And so now, where's the other 1 or 9 in this row was the question I intended to ask next. Okay, so this is purple 1, 9. Where's the yellow 1, 9? Well, the yellow 1, 9 in this row is with the yellow 2, 8. It's with either the 2 or the 8. So then where's the yellow 1, 9 in this column? Well, the yellow 1, 9 in this column, now it can't repeat on a Renban because that would be repeating the Renban that exists in row 5. And so it has to actually go here. was the way I sort of saw this. But it's still exactly what Simon was doing, which is to say we're going to count all of the 1-9s and think about them. And so now the way this sort of proceeds is, okay, so now there's a purple down here. So there's a purple over here. So now this yellow is on this Renbon, so this Renbon's all yellow. And so we have both extreme length 3 Renbons from the beginning. And you can get the digit that Simon got here now by asking, okay, where does the yellow 1-9 go in this box? The yellow 1-9 in this box can only go here, because if I put it on the length 3 Renbon, it would repeat that length 3 Renbon. And so then we ask, okay, where does the yellow 1-9 go in this column? And it can't go here or here, because that would repeat it on a length 3 Renbon, so it goes here, and then we end up here, and now we converge back to exactly where Simon was. So Simon identified that it was the counting the 1-9s that was important, and then got exactly the digits that I intended you to get, or exactly the pattern that I intended you to get, because this now tells you, okay, so this has to be 9 and this has to be 8, because if this was 1, this would be 2. But in a way that was sort of like putting together the two pieces of logic that I think are a little more clear separately, if you think about the length 3 and the length 2 Renbon separately. I'll notice, just because it's cute, after I set this puzzle, there's an accidental thing that happens here where you can ask about what happens with 1 and 9 in this row. Well, where's the 9 going to go? Well, the 9 can't possibly go here, because if the 9 was on this length 4 Renbon, it would need an 8, and it can't have one. The 9 can't be on this length 3 Renbon. Can't be in here, it's a 1-9 pair. Can't be here, because it would repeat on a length 3 Renbon. Can't be either of those places, it would repeat on length 3 Renbon. So actually, if you look at in row 3, you get that this is a 9, and then you now ask where the 1 goes, and you actually get that the 1 now, because there's a 1 over down here, the 1 now has to go over here, as this would be 1, 2, 3, 4. And so then you sort of can go off to the races from there. But that was completely unintended. I only noticed that in like my third test solve. I was like, wait a second, I actually really packed this this row, so it lets you sort of circumvent some extra logic if you want. Alrighty, well, that was a lot of fun. Thank you to Simon for solving the puzzle. That was a lot of fun to see. Hopefully, those of you who did this puzzle had fun with it. I really enjoyed setting this one. Question for or sort of proposal. I'd like to see a version of this rule set with arrows. So I don't know if I'm capable of setting it. But there are some number of length 2 arrows. I think there are 16 length 2 arrows in total. I'd love to see if you could make a version of this that just used that. So any of you fancy arrow setters in the chat, I'd be interested to see how you do this. So the first version of this puzzle I did used like it was sort of like a kitchen sink one where I used every kind of clue, and so there are whispers and Renbon and X's and V's, but the V's couldn't be the same as the whispers or whatever, et cetera, et cetera. So yeah, I'd be really interested to see if you could do this with length 2 arrows. I'm almost positive you could, and that it would be cool, but I don't think that I don't know that I could do it. All right, I'm gonna take a real quick break. I'll be right back, and then we can do more puzzles.